Perpendicularity is an orientation control. It's particularly used for controlling features at 90 degrees to each other, so it can be used for controlling holes and pins back to datum surfaces. Depending on the feature being measured, the elements are either central elements such as an axis or a surface element such as the surface of a feature. It's quite common for perpendicularity to be used as a refinement tolerance as a way of qualifying a datum. Remember, when you're outputting perpendicularity, you're not looking for an angular error, you're looking for a deviation from nominal and thus magnitude in either inches or millimetres. A common example of perpendicularity is on a circular feature such as a pin or a drilled hole, which has to be 90 degrees back to the datum plane which it references. And this is an example of a feature of size measurement. An example of a surface feature could be a right-angled 90 degree surface to a datum surface. Here we have an example of perpendicularity on a drawing which has been auto-ballooned. Perpendicularity is described as two 90 degree lines to each other. In this example, it has a total tolerance band of 0.1 millimeters, and you always reference a datum feature, such as datum AB, because it's an orientation control back to a datum. If we looked at first principles and how we would inspect this, we would use an angle block that is at 90 degrees and then a clock. As long as the angle block establishes the datum, the clock deviation would give you how unperpendicular the feature is to the datum. However, it's much easier and quicker to establish the datum and the perpendicularity using an optical shaft measurement system, such as the example we have here. I'm now going to demonstrate how this works with a shaft measurement system, which also has a tactile probe on it to establish the perpendicularity. At the start of the measurement routine, it's establishing its orientation and establishing its datum system AB. It's then going to change to the tactile probe to measure the perpendicularity and thus measure the plane on the 90 degrees to the axial datum.